All right, today we are going to be talking about graphing quadratic functions. We're going to talk about their properties. We're especially going to focus on being able to recognize what makes a function quadratic. We'll talk about a quadratic function and its table of values. We'll talk about that pattern. And then we're going to identify the x-intercepts of a quadratic equation from a graph. Remember, our x-intercepts are going to be points on the x-axis. So that's going to be our focus for today. So when we talk about quadratic equations, these are these sort of U-shaped graphs that you see. And we call these parabolas. So the U-shaped graph that a quadratic equation makes is what we call a parabola. That is the name of the U-shaped graphs. When we talk about being able to recognize a quadratic function, it's any polynomial where our degree is 2. So that means it has an x squared. It might have 3x squared. The biggest exponent in your polynomial, your equation, your function, in order to be considered quadratic means degree 2, so it's going to be x squared. The next thing we'll talk about here is some basic vocabulary. So as we talk about our vocabulary, the first thing, parabola, that's going to be the name of the graph for a quadratic equation. So anytime we have these U-shaped graphs, those are always going to be called parabolas. So parabola is the name of the graph for a quadratic equation. X-intercepts, these are the points on the x-axis. So points on x-axis where the parabola crosses. So the point on the x-axis where the parabola crosses. So for example, this would be an x-intercept. This would be an x-intercept. Any point where our parabola, our U-shaped curve, crosses the x-axis, that represents an x-intercept. Our axis of symmetry, vertical line, passes through the vertex. We'll talk about what the vertex is here in just a minute. But it's a vertical line, passes through the vertex. It splits the parabola in half. So you'll notice that if we have these U-shaped graphs here, if I draw a vertical line that splits it in half, we say parabolas have symmetry. So if I take the left side of this parabola and I took this point here and I reflected it to the other side, I took this point here and I reflected it to the other side, it's a mirror image where if we folded the parabola across that vertical axis, those points would perfectly align with the other side, which means that our parabola has symmetry. The next part we're going to talk about is concave up and concave down. That's the direction of opening. So parabolas can open one of two ways. This would be facing up. This would be facing down. So if you take a look at where is the graph tending towards, if you look at where the arrows are pointing, that will tell you whether the parabola is opening up or if the parabola is opening down. Our vertex represents the maximum or the minimum of our quadratic equation. It's where the direction of the graph changes. and it's on the axis of symmetry. So I'll label this in the graph up above. This point here at the bottom would be our vertex. The point here at the top in the middle on the axis of symmetry would also be the vertex. So it's the point on the axis of symmetry where the parabola changes directions. Here we're decreasing to increasing. Where it changes directions represents our vertex. So our maximum or minimum, this always happens at the vertex. We're talking about the y values of our parabola. So if we have a parabola that opens up and a parabola that opens down, the maximum or minimum will always be at the vertex. Think about our y values here on our graph. Here's the y-axis. This is the smallest y value. So it's the minimum. Think about this being like the top of a mountain. Here, our vertex represents a maximum. It's the highest point that our graph reaches before going back down. So I'm going to help everyone here through a couple of these charts. I'm going to talk you through the first one, and then we'll talk about the second one together. Or I'll at least give you guys an opportunity, then we'll go over those answers. So we see a U-shaped graph. That means it's a parabola. It's quadratic. So for example, we know that the biggest exponent in this graph, now I'm going to give you the equation. We're not going to talk about it today. But I would say this would be x plus 1 squared minus 4. So our equation would be y equals x plus 1 squared minus 4. You'll see our biggest exponent is 2. That's what makes this equation here a parabola. So I'm going to go ahead and clear my screen because I don't want to take away from what we're really getting at here. But our vertex, we will always write as an ordered pair. The vertex will always be at the top or the bottom of your parabola. It's kind of that middle point where my parabola switches from decreasing to increasing. So it's always kind of think about it as the midpoint of your parabola. That is my vertex, and it has the ordered pair, -1, -4. Now, this parabola has a minimum. The minimum value is always going to be our y value. So what is the minimum value? The minimum value is y equals -4. So when we talk about a maximum or a minimum, we are going to be talking about the y values. Doesn't matter what the x value is. What's the y value of your vertex? That's going to represent your maximum or minimum. This parabola opens up. So you'll see that the arrows are pointing up on the graph. It's going up towards positive infinity. So this one is concave up. Our axis of symmetry is the vertical line that splits the parabola in half. So we have two equal parts. So it's a mirror image. It has symmetry across that vertical line. This is a vertical line going through the vertex. Remember, vertical lines have the equation x equals. Where does it hit the x-axis? Well, it crosses through the x-axis at -1. You'll notice that's the same coordinate as the x-coordinate of your vertex. So our axis of symmetry here is x equals -1. Then we're going to talk about our x-intercepts and our y-intercepts. X-intercepts is where we cross the x-axis. So the first one here would be at 1, 0. You can say 1, 0 or just x equals 1. The other one we have here is at x equals -3. We can have at most 2 x-intercepts for a quadratic equation. We could have 1, we could have 0, but the most you'll ever have is 2. And then when we talk about our y-intercept, where do we cross the y-axis? That's our vertical axis. We have 0, -3 is that ordered pair. You can say 0, -3, or you can simply say the y-intercept is y equals -3. I'd like you guys to fill in the criteria, the characteristics for the next graph on your own. Okay, I have my table filled in for you. I'm going to talk you through how I came up with those answers. Our vertex is 0, 10. That's the point at the top of our parabola here. That x-coordinate is 0 because the point is on the y-axis. We have a maximum value of y equals 10. We're looking at the y-coordinate of our vertex when we talk about a maximum or minimum. Here we're talking about our parabola goes all the way up, it gets to 10, and then we never get a y value higher than 10 because we go back down. So our maximum value is y equals 10. Again, focus on the y value. It's concave up. Our parabola is pointing down, going towards negative infinity. Our axis of symmetry is the vertical line that divides the parabola into two parts, creates our symmetry. It's a vertical line. Where does it cross the x-axis? At 0. You'll notice that's the same coordinates of your vertex. X equals 0. You need to write your axis of symmetry as the equation of a line because we're writing an equation for that dashed line that we drew there. We have x-intercepts at positive 3 and negative 3. And then in this case, our y-intercept is actually also represented by our vertex. So this is the most important kind of criteria that you'll need to know moving forward. You need to be able to identify the vertex. That's the top or bottom of your parabola, that ordered pair. It's a point. It's represented by the maximum or minimum. It's right in the middle of your parabola. When we talk about a maximum or minimum, we're talking about y values. Concave up or concave down is the direction that your parabola faces. Your axis of symmetry is the vertical line. It's imaginary. It doesn't actually exist. We don't draw it every time. But it's the vertical line that divides the parabola in half. Vertical lines have the equation x equals. X-intercepts, where does our curve, our parabola, hit the x-axis? Tell me those x values. Where does our parabola cross the y-axis? You tell me those y values. Now, you have a IXL to work on here. You're going to get to a SMART score of 80, and then you're going to submit a screenshot of that to Canvas. Thank you. If you have any questions, please talk with Mr. Tucker. Have a great day.